Hello, good morning. Welcome again to Prof. Neri. That is by Chemistry Made Easy by Neri. So I'm very sorry. Please, there is something I need to on. I need to switch on the main light. Okay. Thank you very much. If today is the first time you're joining us, endeavor to like the video, follow the page, and ensure you always comment. You can equally share the video. So today we will be discussing an important topic, and in our last class we discussed base and alkalis. So we've discussed acid. We are done with acid. We are actually done with a base, and we today we'll be discussing pH and pOH. pH and pOH. We are going to see the following objectives. So at the end of this class, we all should be able to define pH. We should be able to define pOH. Then we should be able to define or define pH values. Then we should be able to understand the pH scale and the pH values. Then, as well, we should be able to do or solve some problems on pH and pOH and hydrogen ion concentration or hydrozonium ion concentration and hydroxide ion concentration. Then we should be able to see and note the importance of pH values. What are the importance to us, to the society of pH value? So we are going to begin with the term pH. What is pH? Of course, when you say pH, before we continue, you should know that this P is a small letter. Of course, it's just because I'm writing it as a topic. P is not raised to power, because majority of us used to write it as raised to power. Is the best way of writing the pH is like this. This P is a small letter P, while this H is a capital letter H. So small letter P with capital letter H. Then we have small letter P, then capital letter OH. So I want you to put that at the back of your mind. So sometimes some people call this one power of hydrogen. Actually, it is not really power of hydrogen. We call it potential of hydrogen. So we call pH potential of hydrogen. So, but now we want to see the definition itself. So let's see our objective one, which is the definition of pH. What is a pH? A pH is the measure of the degree of acidity or alkalinity of a substance. It is the measure of the degree of acidity or alkalinity of a substance. So that is pH, as simple as that. The degree of acidity. We want to know maybe the substance you have is acidic. For instance, I gave you something, a substance. You don't know whether the substance is an acid. You don't know maybe it's a base. You don't know maybe it's water. You don't know whether it is acidic, partially or fully acidic, or you don't know maybe it is basic. Then when I give you the substance, then that particular substance, you may test it to know whether the substance is acidic or basic or neutral. We all know that the pH of water is 7. 7 is neutral. Of course, we are still going to discuss the pH scale. Now, like I said the other time, that pH is the measure of the degree of the acidity. When I give you the substance, go and test this substance. If this particular substance I'm giving you is an acid, or if the substance is neutral substance, meaning it is neither an acid nor a base or alkaline, or if the substance is basic, then when I give you, you have many different things we can use to test. But the best thing we normally use to test the pH of a substance, of course, we have a pH meter. And we equally have some indicators that can tell us whether something is acidic or basic or neutral. We have many indicators, even litmus paper. We have litmus paper. That's what we call the litmus test. Then we have indicator that can easily show if we have methyl we have naphthalene, we have methyl red, etc. And we have indicator, when we talk about indicator, we have indicator, if it is an acid, it will turn blue litmus paper red. If it is a base, it will turn litmus paper blue. So we are coming to that aspect when the time comes. But today, we have seen it that a pH can be defined as the measure of the degree of acidity and the alkalinity, whether the substance is an acid or is acidic, or alkalinity, whether the substance is basic or alkaline of a substance. And what of pOH? pOH can actually be defined as the degree of that same acidity or alkalinity. But in this case now, we are going to be focusing more on alkalinity, the degree of alkalinity of a substance. So pOH is the measure of the degree of alkalinity of a substance, of course. Nobody will ask you for now to define pOH. Now we have mathematical expression or mathematical definition of pH and pOH. Now, the mathematical definition of pH, please, I want you to focus on this formula. It is very important because we will be making use of this formula in our calculation. Our pH is equal to negative logarithm of hydrogen ion concentration to base 10, or our pH logarithm of hydrozonium ion concentration to base 10. Now look up. Stop writing for a moment because I know you are writing from there. Now, if I ask you to define pH, you give me the theoretical definition as the measure of the degree of acidity or the degree of alkalinity of a substance. I will give you your full mark. Then mathematically, if you define your pH as the negative, look at this. I think you can see this negative. Negative logarithm of hydrogen ion concentration. I mentioned the one concentration. There is in chemistry, there is difference between this and this. This is your normal bracket. This one is just hydrogen ion placed inside the bracket. But in chemistry, we refer to this square bracket. This is what we call square bracket. We refer to this square bracket as concentration. So this is hydrogen ion because it is H plus. It's hydrogen ion. That is your cation. Hydrogen ion concentration. Hydrogen ion concentration. So, or I told you the other time that when you ionize an acid, you have HCl, aqueous. Why did I put aqueous? Because I don't want to show this. This equation is the same thing if I say HCl, maybe gas, plus H2O, liquid. This thing is the same thing with this. Because this one, I can tell you that this particular equation is HCl aqueous. I told you the meaning of aqueous the other time, that when you dissolve a substance inside water, that is the solvent, solute plus solvent equal to solution. If the solution has or comes from a solvent, which is water, then you call that substance aqueous solution. This is an aqueous solution. It has been placed or poured or added to water. So this is an aqueous solution. So instead of writing this, I may decide to write this. If you are writing this, of course, definitely if you ionize this, H will take this one and Cl will take this one. We have done that in our last class. So that's H plus aqueous. I'm putting aqueous plus Cl minus aqueous because it is an ion. Now, but if I want to write this one, normal, this one will split just the way you have it there. H plus and Cl minus. This H plus will now join this. You now have H2 plus H1 will give you H3, H3O. That's going to give you H3O plus aqueous plus your Cl minus. So when you have your hydrogen ion concentration in a solution, it appears in form of hydrozonium ion concentration. That is it. It appears in form of hydrozonium ion. So when you have hydrogen ion in solution, it appears in form of this hydrozonium ion. So now, looking at this, because it is pH, you have pH equals to negative logarithm of H plus, that's concentration 10. That's negative logarithm of hydrogen ion concentration is 10, or negative logarithm of hydrozonium ion concentration into base 10. Then there was a time I was checking through the past question. They said, which of the following accurately defined or is the formula of pH? I am very sure that you have done this thing at school, logarithm, because we are going to be applying logarithm in this case. Then I'm also sure you have done logarithm, you've done indices. So in your SS1 you must have done logarithm or indices. So the knowledge is very good here. Now, do you know, I can tell you that my pH, because what value do we have here? This is logarithm L. What value do you have here? Is -1. If you go back to your logarithm, if you have 2 log 5, it's the same thing as these two can come up here. It's the same as log 5 raised to the power of 2. If you can still remember. Or let me say x log y is the same thing as log y. This x will come up here. Do you understand? So maybe log the base something, any base, let's say base 10 or whatever base you have it. Now, if you remember, this one is -1. If I now have minus x log y base k, if I have minus x log y base k, this minus s will come up. You are going to have what? Log now y raised to the power of what? Minus x, then base k. Did you remember in mathematics, negative index, when you have x raised to the power of -1, is the same thing as 1 over x. When you have x raised to the power of -2, is the same thing as 1 over x raised to the power what? X raised to the power 2. This negative will leave, having your division, because negative can change to division, division can change to negative. The same thing applicable to this one. So this one is the same thing as log 1 over what? Y raised to the power of what? X base k. If you can still understand your mathematics. Well, I'm not teaching mathematics here. I'm only just reminding you something. Because in the JAM, it was a JAM question. When I saw the question, I didn't see this. This wasn't there. The only this I saw there, they removed the negative. No negative here. No -1. So since there is no -1 here, that is not the answer. There must be negative, and these two were not there. Now, but instead, this is what they place there. This -1, when it comes here, you have minus log concentration, hydrogen ion concentration, base 10. This negative logarithm, hydrogen ion concentration, base 10. You know this thing is the same thing as log hydrogen ion concentration raised to the power of -1, that is coming from here, base 10. So from here now, remember my law, the negative index in logarithm. So this one is going to, or in indices, this one is going to now be log 1 over H plus concentration base 10. Yes. So what I want to write here is you may have this one to be positive here. If this minus 1 goes up here, that's 1 over concentration of hydrogen ion concentration base 10. So this and this is the same. Or you have log 1 over H3O plus concentration base 10. So this was the answer that I saw that day. So which is the correct answer? Majority of the students came out, they said that thing has no answer. I said there is answer, not until we now solved it for them. We are going to be doing lots of logarithm calculation here. So get set, and you have to just flash back to your mathematics. Now this is our pH. Now let's go to POH, because I told you the other time I'll be taking the two together. So I will not take pH, finish pH, and come back to pH. I told you the other time that the measure of alkalinity of a substance is pOH. Now, let me now write the formula. The same formula. It's just that this one is, when I was defining acid, according to Arrhenius, any substance that dissolves in water to give you H3O plus or H plus, that's an acid. That's the reason why you are seeing this. They are acting for acid. Then, when it is base, any substance that reacts with an acid to give you water is a base. Now, look at it. Instead of H plus, when you see OH, that is a base. We'll be using OH minus. Anywhere you see OH minus, that one is coming from the base. So my POH now is equal to negative logarithm, the same formula of hydroxide ion concentration base 10. Now this one is just only this. Negative logarithm of hydroxide ion concentration base 10. And of course, you can also work on it the way I work on this one by saying it is log 1 over concentration of OH minus base 10. So this, I want you to put this formula in your mind, or you can jot it somewhere. The formula of pH, we are going to be using either this or this. But me, naturally for your calculation, I prefer you use this. Negative logarithm of hydrogen ion concentration base 10. It's very simple. Then your pOH is negative logarithm of hydroxide ion concentration to base 10. So maybe I should clean the remaining one and stick with this and call them my formula number 1. Let me put it like that as my formula number 1. So I'm going to erase every other one.
Say, I did not understand.
Toshuku, you did not understand because you came late.
You just come online.
So you don't just come online and say you did not understand. That means you will have to. I gave you the time, 9 o'clock. You are expected to just be on that page at exactly 9, waiting for me. I may delay a little bit, maybe network or one thing or the other. So you have to wait there. You have to wait for me. And immediately you see me online, you will just click on it and you follow. That's the reason why you have to follow. So that you don't understand, you go back and rewatch. I'm not going to re-explain now. So in order to keep our time, because I'm not going to spend more than 1 hour, 30 minutes. Yes. So this is my pH. My pH is negative logarithm of hydrogen ion concentration to base 10. While my pOH equals to negative logarithm of hydroxide ion concentration to base 10. These two are the formula 1. Let's take it as number 1. That's, ask you to calculate pH. Ask you to calculate pOH. Now, we are going to see the second formula, which is, you have this, I'm done with definition now. We want to go to PSK. So PSK will lead me to the second formula. And we are going to see the pH value on it. And what is PSK? It's a scale that ranges from 0 to 14. It has values ranges from 0 to 14. Now, we're on PHK now. It adds values that ranges from 0 to 14. And let me draw like this. We have 0 here, and we have 14 here. In between, it's 7. So, let me see, 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6, 7. Then we have 8, 9, 10, 11, 12, 13, 14. Now, this is exactly, let me make this one long. I have my reason for that, which I'm going to tell you. Now, we have our value for pH. When this is our pH scale, it ranges from 0 to 14. And from 0 to 7 is acidic. Meaning from 7 downward, it is increasing this way. That is, this my arrow means 6, 5, 4, 3, 2, 1, 0. This increasing acidity. You must have done pH in your junior class. Then this one increases like this. It increases to that place. This is increasing alkalinity. Increasing alkalinity. Now look at it. Do you know what this means? Let me come back to this page. It means 5, the one with highest pH is highest, that the one that is the most acidic here is 0, followed by 1, 2, 3. 1 is not as acidic as 0. pH of 2 is not as acidic as 1. pH of 3 is not as acidic as 2. Now, when you have your strong acid are located around here. From
it seems you are fast. They are saying they don't understand.
Who is saying it seems I'm fast?
No, I'm the one just saying it seems you are fast.
Who is the person again?
Celia and saying, sir, please, I don't understand, because she complained of network at first.
Celia, if you're complaining of network, you still have opportunity to go back and rewatch. You understand? So we're on PHK. Please, I want to see how many people are online.
We have 8.
Now, please, I want to know if anybody online is getting it. If you're online and you're getting the process, then I want you to type it at the comment section to signify whether you are understanding or not. So I want to wait and see your comments before I continue. I'm waiting for you at the comment section. Do we have anybody that is getting it from the beginning?
I don't think anybody is applying. Can you just give us a little brochure? Sorry.
Hello, this is video. This is online work. If you want me to repeating it, that's the reason why it is video. You will go back and rewatch. Do you understand? Meaning you cannot, because of network in your place, now be telling me when you log in again I should go back. So the best thing is for you to maybe you go offline. Then when we are done with the video, then you come back and rewatch yourself. Then you are able to watch from the beginning. Or better still, you can follow from where you are. You won't just log in and tell me, please, you did not understand. How will you understand? You know, I have been telling you physically that when you come late to the class, you miss the beginning of the class, you can't get it any longer. So you also have to be so curious and come early to your class. No, it's not, making fun any longer. So we are talking about PHK. I'm not going to go to the beginning. I'm only going to talk about PHK. So we are talking about PHK. what did I say that you did not understand by saying a pH scale ranges? It has value that ranges from 0 to 14. It has pH value that ranges from 0 to 14. Do you understand that simple statement? It has pH value that ranges from 0 to 14. Now, then the pH, when you have it, it is divided into two. The first 7, that is from 0 to 7, is acidic. From 8 to 14 is basic or alkaline. Now, in between that 7 itself, that pH is neutral. That is where H2O is. H2O, carbon 2 oxide, and the rest. They are neutral. They are neutral compound. pH 7 is neutral. Just like your water is neutral. Now, anything that makes you to leave this place and have a value here less than 7, when your pH value is less than 7, then is less than 7 means it is a value that is less than 7 that start from 0, 1, 2. That's 6, 5, 4, 3, 2, 1, 0. You can have 2 point something, 1 point something, 3 point something, 4 point. That means that is an acidic. It is acidic. Then it is acidic. When your pH is greater than 7, it means the number is greater than 7. That is 8 to 14. Then it is basic, or it is an alkaline. Now, if you have your calculation and the value they gave you or you got from your pH scale or your pH meter reads 5.6, it means 5.6 is less than 7. It means that region is acidic region. That substance is acidic. Maybe you take your soil sample, then you test it with a pH meter, or you test it and you get a value of 4.5. 4.5 means that place, that ground, that land is acidic. If you get 10 point something, it means it is basic. And I told you, as you move from here to this place, there is an increasing acidity, meaning that the acid is getting more concentrated as you travel from here like this. 0 has the highest acidity, followed by 1. The value, if you get 0, meaning it is the most acidic substance. If you get 1, meaning that one is less than this value, this particular value. So what is difficult in this thing that I've been explaining that we didn't understand? You just need to stay in a place where nobody is disturbing you. You cannot be listening to a teacher online and you are still playing with your family. That is getting me upset, actually. Or maybe you're discussing with your parent, you didn't log in on time, and lecture is going on, and you're expecting to get it. You cannot get it. This is chemistry. It's different from other subjects. Good. I'm going to continue. So this is my pH scale. I said pH 7 is neutral. And you want me to be going back and going back and going back. My dear, nobody sponsors this program. I am sponsoring this program myself. Nobody gives me money. I am buying data and everything myself. No, going back is not ideal. We are going to continue. Now, this pH of 7 is neutral. And at this pH of 7, anything less than this one is acidic, anything greater than this one is basic or alkaline. So less than this, we have your weak acid is around this region, around 5 to 6, also all those, that area. This place is weakly acidic. Then when you get to this place, you have your strong acid here. When you have between your 8, 9, and 10, they are weakly basic. Then around this place is what? Is what is called strong, what is called alkaline. So that is that about this. And if you remember your mathematics, all these are mathematics. If you remember your mathematics, your 10 raised to power 0 will give you minus, then 10 raised to power 0 will give you 0, 10 raised to power minus 1, 10 raised to power of minus 2, this is 10 raised to power of minus 3, 10 raised to power of minus 4, 10 raised to power of minus 5, 10 raised to power of minus 6, 10 raised to power of minus 7, 10 raised to power of minus 8, 10 raised to power of minus 9, 10 raised to power of minus 10. Please come and attend to this board. 10 raised to power of minus 11, 10 raised to power of minus 12, 10 raised to power of minus 13, 10 raised to power of minus 14. Your teacher must have taught you this. Your teacher must have taught you this by telling you in order to calculate a logarithm. You understand? If you have log 10, we give you 1. Log this one will give you 2. So this one, I can equally use this value. This value, 10 raised to minus 2, is still serving as this same value of 2. 10 raised to minus 3 is still serving as this value of 3. 10 raised to minus 5 is still serving at this value of 4, and so on and so forth. So this is my pH scale. This is my pH scale. Now, I told you from here, I'm going to decode my formula, my second formula. I have written my first formula. The first formula is pH is equal to negative logarithm of hydrogen ion concentration to base 10, or POH is equal to negative logarithm of hydroxide ion base 10. Then we have this. If I want you to understand something, that if you have water is a liquid, and it will ionize partially. If water ionizes partially, it will give you H plus. This we have done before. Aqueous plus OH minus aqueous. I think you understand that partial ionization. Now, I want you to understand that now the concentration of hydrogen ion concentration is the same when you check your pH scale. From 0 to 7 is acidic. That is where you have your hydrogen ion concentration, hydrogen ion. Then your 7 to 14 is basic. When you start, 7 itself is neutral. Higher than 7 to 14 is basic. Then less than 7 is acidic. So the value of this one, H raised to power, I say H raised to power. So hydrogen ion, that's H plus concentration, is the same thing as the value of OH minus concentration, and that is the same as the value from the highest. Those values I wrote, 10 raised to power minus something, 10 raised to power of minus 7. What does that mean? It means from the pH scale, when I drew the pH scale, from 0 to 10, if you to 7, that is, I put on that 7, 10 raised to power minus 7, that's from 0 to 10 and to 7, that is acidic. To less than 7, just around minus 7 is acidic. Then above 7, that is also basic. At 14, I put 10 raised to power minus 14. That is half of the pH scale. Because the pH scale can be divided into two. The first half, which is 0 to up to 7, is acidic. Then above that 7. So, but on that spot of 7 is neutral. I want you to understand. Anything, it's 6.9 something or 6.9, it's becoming acidic. Anything 7.1 is becoming basic. So this and this is 10 raised to power of minus 7, and we normally measure this in mole per dm³. So it means hydrogen ion concentration is equal to 10 raised to power minus 7 mole per dm³. Hydroxide ion concentration is also equal to 10 raised to minus 7 mole per dm³. Then if you now want to talk about ionic equilibrium of the water now, ionic equilibrium of water, that is Kw. Ionic equilibrium of water is this and this. I will multiply this if you want to write the equilibrium constant. Sorry, you are not in SS3, you have not done, or SS2, you have not done equilibrium. There is what we call equilibrium constant. So this is H plus multiplied by OH minus. Now, it means your ionic equilibrium of water is equal to, this is 10 raised to power of minus 7 times another 10 raised to power of what? Minus 7. So this value I told you is equal to minus 7. This value is also equal to, this OH minus concentration is also equal to minus 7. Kw now equals to, now this is indices now. In indices, we pick 1. I'm going to pick this 10 raised to power of minus 7 times we change to what? Plus in indices. Then you have your minus 7 again. Then your Kw now, ionic equilibrium of water, is 10 raised to power of minus 7 plus times minus will give you minus 7. Then ionic equilibrium of water now equals to 10 raised to power minus 7 will give you what? Minus 14 mole. Now, remember, I am not working with the unit. If I want to get this unit, this one, the unit of this one is mole per dm cube. The unit of this one is also mole per dm cube. Let's calculate the unit here. Kw equals to, the unit of this one is mole per dm cube. That's this one. Then times, the unit of this one is also mole per dm cube. Now, my Kw now will be equal to, we have mole times dm cube times this one. So you rearrange. This one will now be just like, this one is mole times dm cube. You know, naturally it is mole per dm cube like this. Times mole per dm cube. Now, if you now want to do it, that's the meaning of this thing. This one I've written. That's the meaning. Or let me write it that way. We have mole per dm cube. That's the reason why I use minus 3. Minus 3 there is showing the power. This is mole per dm cube times this mole per dm cube. Now, ionic equilibrium of water now is equal to, you multiply this and this. Mole times mole will give you mole times mole all over dm cube times dm cube. Remember, in indices, this one means mole raised to power 1. Mole raised to power 1. So it's just like you have x times s. That's s squared, isn't it? It's s squared. So this is mole raised to power 2 over dm cube times dm cube. You have to use indices. Don't say 3 times 3. No. You pick your dm cube. You pick one dm cube. You pick your dm. Then you say 3 times we change to what? Plus 3. That will give you dm raised to power of 6. Right? So this one will give you dm raised to power of 6. So you have mole raised to power of 2. This one is, let me just give a very simple illustration here. It's just like s times s over y raised to power 2 times y raised to power 2. This is s raised to power 1 times s raised to power 1. You pick one x 1 times we change to plus 1. This is laws of indices over, you pick y raised to power 2 times we change to plus, then plus 2. This is x raised to power 1 plus 1 is what? 2 over y raised to power 2 plus 2 is what? Is 4. Did you get it? So the same way. So this is mole raised to power 1 times mole raised to power 1. So that 1 plus 1 will give us 2. That's this 2. You just pick one of these. Pick one of this, one of the dm. This is it. Then 3 plus 3. This time we change to plus. 3 plus 3 will give us 6. So if you are bringing it down, Kw now is equal to mole raised to power 2. If this one is coming up, it's becoming dm per dm raised to power 6 minus 6. So you have mole raised to power 2 dm raised to power minus 6. That's going to be the unit. So this is mole 2 mole squared dm raised to power of minus 6. So that is that. What does that mean? Do you understand what this thing means? It means this kW, the value of this, where is it? The value of it, come back to this place. It means the value of this kW, the ionic equilibrium of water. Let me explain again. Maybe no, SS1. You are coming up. This is chemistry. You need to start blending into chemistry. Now, we started from water. This equation of water. If you ionize water, H2O will partially ionize into H plus and OH minus. Then the concentration of H plus is the same thing as concentration of OH minus in PSK, which gives us 10 raised to the minus 7. I told you this place and this place in the PSK. Then it means, and I say equilibrium of water, the ionic equilibrium of water is equal to, you write concentration of this times concentration, not plus, times concentration of this. So concentration of this times concentration of this, where am I though? Concentration of this times concentration of this, not plus. Handkerchief, please. Concentration of this times concentration of this, which is what we have. Now, my ionic equilibrium of water now is equal to the concentration of hydrogen ion concentration is minus 7, which I told you here. Where is it? And this OH minus is also, concentration of OH minus is also 10 raised to the minus 7. So this one, Kw, is equal to 10 raised to the minus 7 for this, times, there is times here, this one, 10 raised to the minus 7 for this. Now, remember your logarithm, or your indices. Your Kw now equals to 10 raised to the minus 7 times we change to plus. This is it. Then minus 7. Then you have Kw now equals to 10 raised to the minus 7 minus 7. This is plus times minus will give us minus. Then from here, minus 7 will give you what? Minus 14. Then we calculated the unit here, and we have what is it called? Mole raised to power 2 dm raised to power of minus 6. So that is that. Now, what does that mean? Come back to this place. It means Kw, what's the value of Kw? 10 raised to power minus 14 is equal to this concentration times this concentration. This is what we got to be equal to 10 raised to power minus 14. It means I want to substitute my 10 raised to power minus 14 for this. So instead of writing this one, I can say therefore 10 raised to power of minus 14 is equal to concentration of hydrogen ion and concentration of hydroxide ion. Or I can start with this one. Concentration of hydrogen ion. Please, I want to say, are they seeing this side? So concentration of hydrogen ion and concentration of hydroxide ion equals to 10 raised to power of minus 14. So this is another formula. Our first formula is this. pH is equal to negative logarithm of hydrogen ion concentration base 10, while pOH is equal to negative logarithm of OH minus base 10. Now, we have another formula now. What is the formula? The formula now is concentration of H plus and concentration of OH minus is the same thing, is equal to 10 raised to power minus 14. In case we give us another question that is asking us, if they give us OH minus, concentration of hydroxide ion, and they want us to calculate the concentration of hydrogen ion, this is the formula you will use. Remember, if they tell you calculate pH, this is the formula you will use. If they tell you calculate pOH, this is the formula you will use. If they now tell you calculate hydrogen ion concentration when you are given hydroxide ion concentration, this is the formula you will use. And number 3 formula, this our third formula, is pH plus pOH. pH plus pOH all together is equal to 14. as assuming I'm seeing you physically, I will have asked you, what do I mean by 14? If you check your PSK, everything is got to it's ranging from 0 to what? To 14. So, and here is increasing acidity, here is increasing alkalinity. That's here is increasing the concentration of H plus, here is increasing the concentration of OH minus. Everything together will give you 14. So sometimes they will give you pH, or you have calculated your pH, they still want you to calculate your pH. You just use this formula. If you already have your pH, just say pH plus pH equals 14, then you get your answer. So I'm done with pH scale, and the pH values. And if you want to know the definition of pH value, it's a measure of the hydrozonium ion or hydrogen ion concentration in a dilute solution. The measure, you want to measure the pH value, you want to measure the value, the hydrogen ion concentration or hydrozonium ion concentration. Let me pick one. You want to measure the hydrogen ion concentration in that solution. That is what we call the pH value. The measure of the hydrogen ion concentration or hydrozonium ion concentration in a solution is called the pH value. So without wasting time, I've given you three good formulas. The first formula I gave you is pH equals to negative logarithm of hydrogen ion concentration to base 10, or POH equals to negative logarithm of hydroxide ion concentration into base 10. Let me put the formula here. pH equals to negative logarithm of hydrogen ion concentration to base 10. POH equals to negative logarithm of hydroxide ion concentration to base 10. Then I gave you hydrogen ion concentration times hydroxide ion concentration equals to 10 raised to the power of minus 14. This is 1. This is 2. Then lastly, I gave you pH plus POH equals 14. This is number 3. So we are moving to calculations on pH and POH. How many people do we have? Any comment? Okay. Now we want to see calculation on pH and POH. Let me get this calculation. What examples? Now, question number 1. What is the pH of a solution containing what's the pH of a solution containing a 0.01 mole per dm³ of HCl, B 0.01 mole per dm³ of H2SO4. Now look at this question. What is the pH of a solution containing A 0.01 mole per dm³ of HCl, B 0.01 mole per dm³ of H2SO4. Now I'm going to write my solution. We are told to calculate pH. What's the formula for pH? pH is equal to negative logarithm of hydrogen ion concentration to base 10. Now, they said A is 0.01 mole per dm³ of HCl? The answer they gave us here is HCl. You are going to pick your HCl. Your HCl. I put aqueous because I want to ionize. I don't put liquid. If I put, what is it called? Gas or whatever, I'm going to be adding it to water. HCl aqueous will ionize to give me what? H plus and what? Cl minus. It will give me H plus aqueous plus Cl minus aqueous. That's it. Now, from here, what is the value of, look at the H plus we are looking for from this equation. Look at it, look at the H plus we are looking for. Now, we need to get, they gave us the value, look at it. They said, what is the pH of a solution containing? Is 0.01 mole per dm³ of HCl. They did not say 0.01 mole of per dm³ of H plus, but they call it HCl. But when you look at it, this is 1 mole. The number written here is 1. This is 1 mole and this is 1 mole. You understand? If this is 1 mole and this one is also 1 mole, then the value given here, HCl, this is the value of 0.01 is for HCl, which is for this one. 0.01 mole. Mole per dm³ means in 1 dm³. Let me put it together per dm³. If it is 0.01 mole per dm³ and it is 1 mole, when this one comes to this place and it is also 1 mole, it's going to be what? The same 0.01 mole per dm³. But if it is 2, here, if this place is 1 mole and this one is 2 mole, you have to multiply this one by 2 when you get to this place, just like cross multiplication. To this and this will give us this. So now we have gotten the value of our hydrogen ion concentration. We will now say therefore my hydrogen ion, the concentration, this is the unit, the concentration of hydrogen ion concentration. The hydrogen ion concentration is 0.01 mole per dm³. And the best way to solve this is by turning this value to standard form. That is 1.0 times 10 raised to the power of minus 2. 1.0 times 10 raised to the power of minus 2. You understand what it means? If you want me to still teach you how many zero do you have here? 1, 2, that's minus 2. But if you have it in that primary school, we say 0.01 is 1 over 100. You say 100. Then this is 1 over 10 raised to the power of 2 will give you 100. 1, 2. Then when you remove this one, it becomes 10 raised to the power minus 2. So that's 1 times 10 raised to the power minus 2, which is the same thing as 1 times 10 raised to the power of minus 2 mole per dm³. This one will help you very well to be able to apply your formula. What is my formula? My formula, we are told to calculate pH equals to, is the border line? Is the border alive? pH equal to negative logarithm. That's my formula of hydrogen ion concentration to base 10. So we now have pH now is equal to negative logarithm of, what is the value of my hydrogen ion concentration? It is 1 times 10 raised to the power of minus 2. Look at it. I'm no more using square bracket again. I'm using ordinary bracket because you cannot be calling, we have written the value, the concentration value. That is the pH value. We have written the concentration value here. So we've written the concentration value, so you don't need this again. It is only applicable when you are writing the concentration. So you don't call it concentration. The value is the concentration. So in this case now, remember your mathematics very well. What do? You will use this one to open this bracket. Remember, so your pH now is going to be equal to minus log 10 times 1. It will give you minus log 1 base 10. You understand? In logarithm, when you are opening a bracket, what happens? This time it will change to what? It will change to, maybe I should listen to you now from the comment section. If you are opening a bracket, I have used this one to open this bracket. I want to write these times. Will I write times or what will I write here? I want to see whether you understand the mathematical concept. I'm waiting for you. Anyone?
Just continue. Directing your back.
So if you don't understand that, the problem some of us are having is we do not understand the mathematical concept. This is pure mathematics. This is pure mathematics. So
Okay, Juliet said plus.
God bless you, Juliet. You are correct. So when you are opening this bracket, minus log 1 base 10, if this times will now change to plus, you will now put plus. God bless you, Juliet. Then you will still use this minus log. Multiply by this, you will now have minus log 10 raised to the power of minus 2 base 10. What did I do? This one, multiply this one. I just wrote this one, I put the 1 in front of it. Times change to plus. Then this one, multiply this one. I wrote this one, minus log base 10. Then I place this one in front of it. Then, for me to have a better mathematics, because plus and minus, when you see it together, it will be giving you a problem. Let me put this one inside bracket. Then it will give me a better calculation, a very neat calculation. From here, can they see this now? pH now is equal to minus log 1. Now, what is log 1 in your calculation? If you have your calculator there, Juliet, are you with your calculator? If you are with your calculator, press log 1. Log 1 will give you 0, if I'm not making a mistake. What is your log 1 giving you? I'm waiting for you. Press your log 1. Has anybody pressed log 1 from his calculator? Just press log 1. We have our minus here. Then press your log 1. Huh? Let me check. Let me see the comment from the comment section. What do you have? Log 1 gives what? Possibly maybe they don't have calculator with them. So log 1 will give you 0. It will give you 0. So this is 0. So I don't need minus 0. There is minus there, minus 0. So you don't need to write this one any longer. This now, plus times minus will give you minus log 10 raised to the power of minus 2 base 10. Now I want you to understand this value very well. I want you to understand this logarithm. Did you remember there is one law of logarithm that this value will come to the front? This value, it will come to this place. If you study your logarithm very well, that minus 2 will come to this place. That power, I think I have done that before. When you have log a raised to the power of x base b, this one will go to the back. It will now be x log a base b. So if you understand that, so this one will go to the back. So it will now be, remember there is a minus there already. So your pH now will now be equal to, there is minus there already, that minus that is there already. You have to be very careful. The minus that is there already, then minus 2 is coming again, then you put the minus 2. There is minus there already, then the minus that is coming again, you put the minus 2. Then log 10 base 10. So our pH now is equal to minus 1, this is minus 1, times minus 2 will give us plus 2. This is 2 log 10 base 10. Log 10 base 10 will give you 1. If you press log 10, it will give you 1. Log 1 is 0. Log 10 is 1. So it will give you 1. So that 2 times 1 will give you your pH now equals to 2 times 1. Then your pH is equal to 2. Now, if I ask, the pH is 2, what does that mean? You see, acidic from your pH scale. You can also put that at the comment section. is your pH going to be acidic or is it going to be alkaline when you calculate your pH value and you have 2? So is the value going to be acidic or alkaline? So you tell me from the comment section. So that is my calculation for number 1. That's for A. Remember, the first thing I did is to write the ionic equation for the HCl. If I want to do this B now, I will equally write the ionic equation for H2SO4.
Would you like say her name is Mercy, Mrs. 1.
Okay.
She said the answer is acidic.
Okay, God bless you, Mercy. Mercy, thank you very much. Mercy is getting a D. Since it is 2, that means our HCl is a strong acid because the pH scale ranges from value of 0 to 14. I mean from 0 to 40, then acidic is from 0 to less than 7. So the 0 is the highest. Now if you look at it, 0, 1, 2. If HCl is 2 now, it means it's a strong acid, very, very corrosive. Now we move to the second aspect. Please, all these things I'm cleaning, you can go back to rewatch the video, and when you rewatch, you will be able to pause. When you are watching, when you get to that aspect, you will pause it, and when you pause it, you will be able to do your calculation. You'll be able to write it down if you want to write. Though I'm going to be sending you the notes. Now, B, we have, they said, what is the pH of 0.01 mole per dm³ of H2SO4? You also write the ionic equation for H2SO4. I want to write the ionic equation for H2SO4. What will this one give you? I told you the other day we were writing this. I said H will pick the one outside SO4. That's going to be H plus, and SO4 will pick this 2. Then it's going to be SO4 2 minus. Then from here you have H plus aqueous plus SO4 2 minus aqueous. So, but in this ionic equation, you need to balance. Check whether your equation is balanced. The atoms are balanced or not. Hydrogen is 2 here, hydrogen is 1 here. Then you need to put 2 at the back of this hydrogen. I didn't balance this because this one was a natural equation. It balanced itself. H is 2, H is 2. S is 1, S is 1. O is 4 and O is 4. So how many moles? Let's check this one to this one. This one is 1 mole, right? This is 1 mole. Why this one is 2 moles? Did you see this now? Now, what value did they give us? They said 0.01 mole per dm³ of H2SO4. 0.01 mole per dm³ of H2SO4. So H2SO4 has that value. You will now put under H2SO4, you put the value 0.01 mole per dm³. Now, remember this one is 1 mole. When it is coming to this place, that is 2 mole. It's going to be 0.01 times 2. If you multiply 0.01 times 2, it will give you 0.02 mole per dm³. So it means now that my hydrogen ion concentration from here is equal to what? 0.02 mole per dm³. Now, you need to do what? We change this one to standard form. When you change this to standard form, it's going to be 2 times what? 10 raised to power 1, 2. We have 2 0 there, that's minus 2. It's got to 2 times 10 raised to power of minus 2 mole per dm³. That's 2 times 10 raised to power of minus 2 mole per dm³. Now, we now have our hydrogen ion concentration. Now I can now use my formula. And my formula says pH equals to negative logarithm of hydrogen ion concentration to base 10 is equals to my pH now is equals to, I'm going to put this value inside there. Negative logarithm of my hydrogen ion concentration, the value is 2 times 10 raised to power of minus 2 to base 10. My pH now equals to, open the bracket just the way we solved the other one. This one times this one to be minus logarithm of 2 is 10. Then this, I use this one to multiply. This one will change to plus. Put bracket minus logarithm of 10 raised to the power of minus 2 is 10. Did you see that? Then your pH now will be equal to, this is negative. Now press log 2. Do we have calculator with us there? Please, I want us to press log 2. Log 2. Log 2 will give us 0.3010. If you press log 2, remember there is a negative sign here. I've written the minus. Then this is 0.3010. So that's log 2. Will give us this. Then plus this minus 2 will come here and meet this minus. So it's going to be minus 1 times minus 2. It will be 2 log 10 base 10. This one will give you 1. Log 10 base 10 will give you 1. So all you now have now is your pH equals to minus 0.3010 plus, so it is plus, because this minus has cancelled this one. Minus times minus, minus 1 times minus will give you plus 2. So it's now be plus 2. Your pH now is going to give you, if you add 2 to this one, that's minus, sorry, you are not adding. Minus 0, that's 2 minus this. Minus 0.3010 plus 2 will give you 1.699. That's approximately 1.70. 1.70. You can see it is very acidic. From the comment section, I want you to tell me, check your pH range or pH scale and see. Between this one we just calculate that gave us 1.70, and the other one where we got pH of HCl where we got 2. This one we got 2 here. This one we got pH of 1.70 here. Which one is more acidic? Which one is more acidic? Is it HCl or H2SO4? Please, at the comment section, you will tell me whether it is HCl that is more acidic or your H2SO4. So that is that one. We are going to see another question here.
Messi said 1.70.
God bless you, Messi. That's 1.70. I believe she's now with her calculator now. God bless you.
Is. She could reply down 0.301.
Okay, thank you. God bless you. So, but there is one I want you to comment on. You know, our HCl now is 2, and our H2SO4 is 1.70. So I want you to tell me which one is more acidic between 2 and 1.70.
That's what she said now. 1.70.
Okay, 1.70 is more acidic, meaning H2SO4 is more acidic than HCl. So thank you very much. God bless you. You are getting it. I hope others online too are also getting it. So I don't know. Please, I want to know if Rosemary is online. Rosemary is not online. Okay, that's good. Please, let me on this fan. The heat is, or maybe you should on this one. Don't worry, I will do that. Okay. So sorry, I just have to on one of my fan. The heat is much. So let's see a question. Let's see where they will be giving us, where we'll be using another formula. Okay, this one, what is the hydrogen ion concentration? Oh, my time is already what is it called? Going. The time is running out already, so I will have to. So let me write this question. What is the hydrogen ion concentration? What is the hydrogen ion concentration What is the hydrogen ion concentration of a solution of pH 8? Of a solution of pH 8. Then states the nature. States the nature of the solution. States the nature of the solution. We just want to know whether the solution will be acidic or the solution is going to be basic. So they say, what is the pH? What is the hydrogen ion concentration of a solution of pH 8? Now, in this question, they are asking for hydrogen ion concentration. They say, what is the hydrogen ion concentration? You mean hydrogen ion concentration is unknown. What is the hydrogen ion concentration of a solution of pH 8? And the pH is equal to 8. Remember our formula. Our formula says pH is equal to negative logarithm of hydrogen ion concentration to base 10. Now this time around, we now want to calculate the hydrogen ion concentration. They gave us the pH itself. So pH is equal to 8. 8 is equal to negative logarithm of hydrogen ion concentration to base 10. Now, when you have this will come down to this place. Anytime you have something like this, it's just like this is what you are looking for. Somebody will say divide both sides by negative log base 10. So which means it's an antilog of this. The first thing is do away with this negative. Multiply both sides by minus. If you multiply this side by this minus 1, and multiply this side by this minus 1, then you are going to have minus 8 is equal to log concentration of hydrogen ion base 10. This negative has come down to this place. Now, the next thing now is to find the antilog. This one will now come down to this place. This log 10, when it comes to this place, it becomes an antilog. It is log here. When it comes down here, it becomes an antilog. Antilog of what is it called? Minus 8. Antilog minus 8. You press the antilog of this minus 8. That's your hydrogen ion concentration. So your hydrogen ion concentration now, I don't know. Do you know how to press antilog online? You press second function log. You will now see 10 raised to the power of minus something. So press your second function. I don't know, maybe second function you will press. Or shift you will press. So you will press your second function. I don't have a calculator here. You press your second function and press log. So that from your scientific calculation, press your second function or your shift. I think maybe shift and log. It's going to give you something like 10 raised to the power of minus raised to the power of something like that. Up. So you will now press minus 8. That's second function, then press your minus 8. Then press equal to second function minus 8, then press equal to. So if you press this, I think you are going to be getting something like 10 raised to the power of minus 8 mole per dm cube. 10 raised to the power of minus 8 mole per dm cube. I don't know if you get your calculator, you can, I don't have a calculator here, so you can press that. You are going to be getting 10. I put unit because you are calculating hydrogen ion concentration. It has a unit which is 10 raised to the power minus 8 mole per dm cube. So, and if you check from your PSK, the one I wrote for you the other time, from 0 to 14, you will see where I put at the upper part where I put 10 raised to the power minus 8. You will discover that place is at the right hand side. It's basic. So the solution will be more of basic. It's going to be basic in nature because of the low concentration of H plus. This value is the same thing as 0. You are going to see 0.0000 something. So but when you put it in this, you have 10 raised to the power of minus 8, or 1 times 10 raised to the power of minus 8, something like that. So from here, you state the nature. The solution is going to be will be basic because of the value, because of the very low value, because of the low value of the hydrogen ion concentration. So if you check when I gave you the 10 raised to the power 8 is around that basic region. So I'm going to give you another question now. And the question is calculate the hydroxide concentration of a solution having a pH. We want to calculate the hydroxide concentration, the pOH now. We want to calculate pOH now. I think I've spent more than almost 1 hour 30 minutes, right?
10 minutes.
Remaining 10 minutes. So if you have this, calculate the hydroxide ion concentration. Calculate the hydroxide ion concentration. Hydroxide ion concentration of a solution having a pH of 4.0. Now, we want to calculate the hydroxide ion concentration. We want to calculate the hydroxide ion concentration. This is what they say you find. Your hydroxide ion concentration is not given. They gave you, but here they gave you pH to be equal to 4.0. So for you now to calculate the hydroxide ion concentration is very simple. The first thing you need to do is calculate you will need to calculate your pOH first from here. You understand? How do you calculate that? How do you calculate this hydroxide ion concentration? If you can still remember. But we need to calculate our pOH first for you to be able to know. You cannot get this one from this one directly. You need to calculate your pOH first. And how do you get your pOH? Your pOH, if you remember that formula, the top formula I gave you, plus pH equals 14. Did you remember? So what is your pOH? That's the one you want to calculate. Plus what is your pH? Your pH is 4 equals to 14. Now your pOH now plus is going to be, when you collect your like terms, it's going to be 14. This one coming to this is going to be minus 4. Your pOH equals 14 minus 4 will give you 10. So our pOH directly is 10. So it is now going to be so easy for us to calculate our hydroxide ion concentration. Then how do you go about that? We have gotten our pOH. We want to calculate OH. Then you now say pOH equals to negative logarithm of hydroxide ion concentration. This is the one we want to calculate now. We have gotten, you cannot use pH equal to negative logarithm of hydrogen ion concentration to start calculating hydrogen. You can also use another method. Another method is you calculate your hydrogen ion concentration from here. Then you will now use the second formula. OH, concentration of OH minus times concentration of this one minus will give you. Maybe I should use that one for you to see. Maybe let me use that one. You will discover that that one is very, very also easy. So you will calculate your H here. Then you will now, when you calculate the concentration of H, you will now use the second formula. Concentration of H times concentration of OH minus equals to 10 raised to the power 14. But you can as well use this one, which is I first calculate my pOH. So pOH plus pH to give me 14. I have given you the value of pH, which is 4, equals to 14. Then I cross multiply, collect the like terms, and my pOH is equal to 10. And from here now, the value of pOH is 10 equals to minus log. What is it? This is the one they said we should find. So what are this 10? What are you going to do? Take this minus to this side, then you have minus 10. That's multiply both sides by minus 1. Minus 10 equals to log this 10. And from here, you will now take this one and find the antilog of minus 10. So equals to, this one has gone, equals to OH, concentration of OH minus. So if you press your antilog of minus 10, it will give you 10 raised to power of minus 10. It's going to give you, we are going to be having 10 raised to power of minus 10. So that's 10 raised to power of minus 10. So check, you can confirm that with your calculator. You're going to be having 10 raised to power minus 10 mole per dm². So you're going to have 10 raised to power of minus 10 mole per dm². For that question, because of our time, I only have like 2 more minutes. So any other question will be given as an assignment in the group platform. So let me go to the last part of it, which is the importance of pH values because of our time. Now, the pH value is so important. It is used in the treatment of water for public supply. Of course, they have to test the water they are giving us, for town supply. Is the water acidic? If our water is acidic, it is not good for drinking. So what is it called? Basic. If it is basic, a water has to be what? It has to be neutral. So they use that method, they use it, the pH value, they test the water before it is being distributed for us. It is also used in the industry to treat industrial waste. So we also adopt this method practically, industrially. We use this method, we use the pH value method. We test the pH of the water or the solution they are using at the industry. To test the industrial waste, all those industrial waste they want to know before they dispose them. If they dispose them into a place, that place is going to be acidic. If that thing is acidic, then it's going to affect the ground where you are, throwing them. So it has to be lined. It has to be neutralized before it is being deposited where it will be deposited. So on this note, because of our time, I have just given this 1.5 hours. So we are going to drawing the curtain into close now. Thank you very much for joining. On the serious note, I know you don't have to be telling a teacher that you didn't understand when you knew you didn't join the class from the beginning. It's just like you are drawing the teacher backward. So, and the other student will just be feeling somehow. They are using data. You're also using data. Everybody is using data to do this. So when you do that, you're drawing them backward. You don't need to do that. You have to stick with them. Where you meet them, you go back and rewatch the video again. When you're watching the clip, rewind, go back, then rewatch again, go back and rewatch again until you are able to get what the teacher is saying. And if there is any question you need to ask, you can come to the group WhatsApp and ask your question. So thank you very much for joining Chemistry Made Easy page. And thank you for following. Thank you for your comments. Thank you, as many of you that commented. We appreciate you. Together with Smart Chemistry. God bless you.